Time travel. It's got to be one of the most exciting and, yeah, one of the most confusing ideas in science fiction and physics. I mean, who hasn't dreamed of going back to fix a mistake or witness some incredible historical event? But then you always crash into that one giant problem: paradoxes. Well, what if I told you there's a principle in physics that might just allow for time travel while neatly sidestepping all of those messy contradictions? Okay, let's get into it.
I mean, that's the dream, isn't it? To have that power, to undo a regret or to nudge history in a better direction. But that very fantasy, that very question leads us straight into the biggest headache in all of time travel theory.
And this is the big one, the classic problem that has tied time travel theorists into knots for, well, decades. It's called the grandfather paradox, and it's basically the ultimate litmus test for any time travel theory. If you can't solve this, you're not going anywhere. Or, any when. So let's just walk through the logic here. You exist, you build a time machine, you hop in, go back, and whoops, you accidentally stop your grandparents from ever meeting. But if they never met, you were never conceived. And if you were never conceived, you couldn't have built the time machine to go back in the first place. Which means you didn't go back, so they did meet, and you were born, which means you can go back and... You see the problem, right? It just breaks your brain. It's a total logical dead end. A statement that's somehow both true and false at the same time. And for a long time, it seemed to make time travel flat out impossible. But here's where things get really interesting. What if the problem isn't time travel itself? What if the problem is just our assumption about what we could do if we went back? What if the universe has its own built-in fail-safes? So this fail-safe isn't just some sci-fi hand-waving. It's a real proposal called the Novikov self-consistency principle. It was developed by the Russian physicist Igor Novikov back in the 1980s. And his argument was that the universe is governed by a fundamental law that basically keeps history on the rails. It has to be consistent with itself. Now, the really subtle, really cool thing about this principle is how it works. It doesn't say you can't try to create a paradox. Go ahead, try. It just says the probability of you succeeding is literally mathematically zero. The laws of physics themselves would conspire against you. Your gun would jam. You'd slip on a banana peel. A bird would fly into your face at the exact wrong moment. Something would happen to make sure the past stays exactly as it was. And this quote from the original paper that Novikov wrote with the legendary physicist Kip Thorne just nails it. It's not some new spooky force. It's just a fundamental rule of the game. Anything that happens on any scale has to fit into the big picture without creating a contradiction. No plot holes allowed in the story of the universe. Okay, so that all sounds pretty neat in theory, but how would it actually play out? Well, to get around the messy, complicated issue of human free will and choices, physicists came up with this beautiful, simple thought experiment, a game of cosmic billiards. And they called this scenario Polchinski's paradox. It strips away all human intention and just leaves you with pure physics. All you've got is a billiard ball, a wormhole that works like a time machine, and what looks like a totally unavoidable contradiction. Oh, right, let's follow the ball. Step 1, you shoot a billiard ball toward the mouth of the wormhole. Step 2, it goes through and travels to the past. Now here's the kicker. Step 3, it pops out of the wormhole in the past on a perfect collision course with its younger self. And in step 4, bam, it hits its younger self, knocking it off course. Which means, and here's the paradox in step 5, the ball now never enters the wormhole in the first place. It's the grandfather paradox, just with a billiard ball. So what gives? Well, according to Novikov's principle, the universe has to find a way out of this. And the solution isn't some crazy dramatic intervention. It's something incredibly subtle, incredibly elegant, just a tiny little nudge. And here it is, the beautiful solution. In a self-consistent timeline, the ball emerges from the past and delivers just a glancing blow to its younger self. Not a direct hit, just a little kiss off the side. And that gentle nudge is just enough to alter the younger ball's path, sending it on the exact trajectory it needs to enter the wormhole, travel back in time, and deliver that very same glancing blow. It all works. It's a perfect, stable, self-consistent loop. No paradox. History is preserved. Okay, a billiard ball has to follow the laws of physics. That makes sense. But what about us? What about people? This is where the self-consistency principle starts to get really philosophical and, frankly, a little uncomfortable because it challenges our most fundamental idea of what it means to have free will. Just look at this comparison. On the left, that's our gut feeling, right? Our everyday experience. I feel free. I can make any choice I want.
But on the right, you've got the cold, hard logic of a self-consistent universe. And it suggests that while you might feel like you have a choice, you can only ever actually make the choices that lead to the history that is already written. And if you're still wrestling with that, the physicist J. Craig Wheeler puts it in a way that just clicks. We already accept that physical laws limit our free will all the time. I can't choose to walk through a solid wall. I can't decide to just flap my arms and fly. Why should this law of chronological consistency be any different? It's just another rule of the cosmic game we have to play by. So this is an elegant solution to paradoxes, but wow, it leaves us with some deep questions. We obviously can't test this today, but let's take a little speculative leap forward. Let's see how physicists of the future might actually try to tackle this stuff by looking at a fascinating fictional paper imagined to be published in the year 2115. So this fictional paper imagines a future where scientists are actually running these experiments, and they immediately hit the wall that Novikov predicted. Every time they try to send a single particle back in time, the experiment just fails. It collapses. It's like the universe is actively protecting itself. But then they have a breakthrough. But first, the tech. How do they even build a time machine? Well, the idea is to use these incredibly powerful, counter-rotating rings of pure laser energy. According to Einstein's theories of general relativity, that intense energy could actually warp space-time so much that it bends time back on itself, creating what physicists call a closed time-like curve, basically a pathway into the past. So how do they get around that self-consistency problem? They use one of the weirdest tricks in the book, quantum entanglement. It's that spooky action at a distance, as Einstein called it, where two particles become linked. What happens to one instantly affects the other. So here's the brilliant solution. They send one particle of an entangled pair 50 milliseconds into the past, while its partner is simultaneously sent 50 milliseconds into the future. The timeline stays perfectly balanced. The net change to causality is zero. Novikov's principle is satisfied, and the universe lets it happen. And here it is, the data. This graph from their fictional paper shows the results. And you can see it right there, those data points on the bottom. They show the particles arriving with a negative time shift. In other words, they were detected before they were even sent into the machine. A successful, stunning demonstration of sending something into the past. And that leaves us with one last, truly mind-bending thought to chew on. Novikov's principle says the past is fixed and can't be changed. This experiment suggests information can be sent back. If both of those things are true, and the universe demands one single, consistent story from start to finish, could it be that events in the future are already casting their shadows backward in time, subtly shaping our present to ensure that history unfolds exactly as it must? A pretty wild thought to end on.